Welcome to a deep dive, and this one's going to change how you think about reliable web services,
Yeah.
databases, really anything that needs to work flawlessly online, at scale.
Mm-hmm.
We're talking about the CAP theorem.
Ooh, big one.
It is a big one, and to guide us through all the nuances, we're diving deep. We're going to be looking at excerpts from Perspectives on the CAP theorem by Seth Gilbert and Nancy Lynch.
Excellent choice. Yeah, it's
Yeah.
one of those foundational concepts that once you get it,
Mm-hmm.
you see its implications everywhere. And
It's one of those things that you can't unsee it.
you can't unsee it. Yeah, it's just like, oh, this is everywhere.
It really is. So
Yeah.
for those who maybe haven't encountered this before,
Right.
what is the core idea behind the CAP theorem?
The CAP theorem, it was introduced by Eric Brewer, and it throws down a challenge.
Okay.
It says you cannot have consistency, availability, and partition tolerance all at the same time in a distributed system.
Ooh. So you got it forced.
Pick two. To make trade-offs, yeah. That's why it's often called a trilemma, because it's three.
3. Yeah, the trilemma.
Yeah.
Okay, so pick 2 out of 3, but which 2? I guess to even start making that decision, we need to be crystal clear
Right.
what each of these guarantees even means in a practical sense.
Absolutely. Let's start with consistency.
Okay.
And we're not just talking about data being correct,
Right.
but that every server in your system gives the same answer to a query,
Okay.
no matter which one is hit.
So it's not enough that the data is accurate somewhere. It has to be uniformly accessible.
Exactly.
Okay, what could go wrong if you don't have that?
Imagine you're booking a flight.
Okay.
You see one seat left, you go to pay, and suddenly it's gone.
Ah.
That could be a consistency problem
Okay.
where one server thought you had the seat, but another one had already given it away.
Oh, that's so frustrating.
Frustrating, to say the least.
Okay, all right, so consistency is about making sure everyone's seeing the same reality. What about availability then? Is that just about the system being up?
It's a little more nuanced than that.
Okay.
Availability in the CAP context means every request gets a response.
Okay.
Now, that response might not be instantaneous,
Right.
and it might not even contain the right data
Oh, okay.
if consistency is being sacrificed, but the system acknowledges the request.
Ah, so it's about responsiveness,
Yes,
even if it's under duress.
exactly.
Okay, interesting.
Yeah.
Thinking back to those real-world examples, are there situations where you might choose availability over consistency?
Absolutely. Think about a social media site's newsfeed.
Okay.
If there's a brief network glitch, showing you slightly outdated posts is preferable to the entire feed being unavailable for minutes while consistency is restored.
Total. Okay, so we've got consistency,
Yeah.
making sure everyone's on the same page. Availability, which is more about responsiveness than pure uptime.
Yeah.
That leaves partition tolerance. What does that even mean?
Partition tolerance, that is about resilience.
Okay.
It means the system keeps working,
Okay.
even if communication between parts of it
Yeah.
becomes unreliable.
Okay.
Think of a network split. Like when a cable gets cut,
Right.
a partition-tolerant system, it'll keep chugging along as best as it can, even if some parts can't talk to other parts.
So that sounds crucial for anything operating on the internet.
Right.
Like, things break
At the time.
all the time. Yeah, but I'm still kind of struggling with why you can't have all 3.
Right.
If my system is partition tolerant, why can't it also be consistent and available?
Let's go back to that network split scenario.
Okay.
Say, on one side of the split, a user updates their profile.
Yeah.
On the other side, someone tries to view that profile.
Right.
Now, if you prioritize consistency, you'd have to block that view request until the network heals,
Right.
because you don't know if they're getting the latest data,
Okay.
and that hurts availability.
But if you prioritize availability and let them see the profile anyway. Right.
You risk showing outdated information, so you're sacrificing consistency.
Exactly. It's a catch-22.
It is a catch-22, and this isn't just some theoretical problem for computer scientists
Right.
to argue about. This is the reality of building anything that relies on a network
Right.
that you don't fully control.
Well, you don't control. Yeah, it's the internet.
Yeah, that's the internet for you.
So how do real-world systems deal with this? Do engineers just flip a coin and be like, I like consistency today?
Well, it's more nuanced than that.
Okay.
There are philosophies
Okay.
and strategies that have emerged,
Right.
often based on the specific needs of the system.
Okay.
Some systems prioritize consistency,
Mhm.
aiming for best effort availability.
Okay.
Others go the opposite route,
Right.
focusing on best effort consistency
Okay.
to ensure responsiveness above all else.
Okay, can you give some concrete examples of how those different approaches play out? Because this is starting to feel
Yeah.
very, very real world applicable.
Absolutely. Let's start with best effort availability, where consistency reigns supreme.
Go.
Think of something like Google's Chubby Lock service.
Chubby,
Rabbit cheeks.
like the baby cheeks for something so crucial.
It's a bit of a whimsical name, yes,
Okay.
but its function is dead serious.
Right.
Chubby prioritizes making sure everyone has the correct view of who has what lock,
Okay.
even if it means temporarily slowing down or becoming unavailable during a network blip.
So it's like a bank vault.
Yeah.
Security and accuracy above all else.
Exactly.
Even if it means things move a little slower sometimes.
Right.
Okay, so what about systems that prioritize availability then? What are those like?
Imagine web caching,
Okay.
like what Akamai does.
Right.
Their entire business is built on getting you content fast.
Right.
They do this by having servers all over the world.
Mm.
If the closest server to you has a slightly outdated copy of a web page, you'll
Yeah.
get that quickly, rather than waiting for the most up-to-date version from further away.
So in that case, it's acceptable to potentially see information that's a little behind
Yeah.
because speed and responsiveness are the priority.
Exactly. It's like choosing between a live news stream
Right.
with potential lag
Yeah.
versus waiting hours for a perfectly edited recording.
It's that trade-off.
Yeah.
Okay.
Yeah.
Okay. So you've got it.
Yeah.
That highlights the core idea. The CAP theorem isn't about finding a winner.
Right.
It's about understanding the trade-offs.
Yes.
And making choices that are aligned with what your system needs to achieve.
Exactly.
But choosing between those two extremes, always consistent or always available, seems a bit limiting.
Mhm.
Are there other ways to navigate this trilemma?
There are. And that's where things get really interesting.
Okay.
Because instead of just picking one of those extremes,
Right.
we can start thinking about clever ways to segment our systems
Okay.
to get the best of both worlds.
Segmentation. So like dividing a pizza into slices so everyone can choose their favorite toppings.
It's not a bad analogy.
Okay.
We're essentially recognizing that different parts of a system
Yeah.
might have different needs when it comes to CCAP.
Right. So maybe this data needs rock solid consistency.
Yeah.
While that functionality
Right.
can tolerate a bit more looseness for the sake of speed.
Exactly.
Okay, I'm starting to see how we can go beyond
Yeah.
just picking team consistency or team availability.
Right, you have more options.
But this sounds like a whole other level of complexity.
It is.
And probably a great place to continue our deep dive.
I agree. We've only just scratched the surface
Yeah.
of how real-world systems grapple with CKP, and the solutions
Oh,
they've come
yeah.
up with are fascinating.
I can't wait to hear about them.
Yeah, it's going to be good.
Yeah.
So you're intrigued by this idea of segmentation, how we can kind of like divide and conquer the CKP challenge.
I am, yeah, it feels like we're moving beyond the theoretical
Right.
into the realm of like practical solutions, which is always exciting. But where do we even begin? How do you decide how to slice the pizza, so to speak?
Well, there are a few different ways to segment a system,
Okay.
each with its own strengths and considerations.
Right.
We can segment by data.
Okay.
By the type of operation, we can even segment by user groups
Okay.
or functionality.
Okay. Let's unpack those. Starting with data partitioning.
Sure.
How does that work in practice?
It all starts with recognizing that not all data has the same importance
Okay.
when it comes to consistency.
Right.
For example, in a financial system,
Okay.
transaction logs, those need absolute consistency.
Yeah.
Every penny must be accounted for.
Right. Got to be accurate.
But a personalized stock market newsfeed
Okay.
on that same platform, a few seconds of delay won't break the bank, so to speak.
So you might have different databases or
Mhm.
even different parts of the same database operating under different CKP priorities.
Exactly.
The transaction data gets the chubby treatment, ultra consistent, whereas the news feed is allowed to be more flexible.
Precisely. Another example is an e-commerce site.
Okay.
Product catalogs
Mm-hmm.
and prices, those need to be fairly consistent.
Right.
Imagine the chaos if every user saw a different price
Oh, yeah.
for the same item.
That'd be bad. Yeah. That's a recipe for lost sales and a lot of angry customers.
Exactly.
Right.
But things like recommendations.
Okay.
Customers who bought this also bought,
Right.
those can afford to be a little stale
Right.
without impacting the core functionality.
This is making me think about all those times I've added something to my cart online,
Yeah.
and then the website crashes
Oh, yeah.
before I can check out.
Yep.
Is that a CIP situation too?
It absolutely could be.
Okay.
Think about the different types of data involved.
Okay.
Your browsing history, which might be used for recommendations,
Yeah.
the product catalog itself,
Mm-hmm.
your active shopping cart,
Okay.
and finally, the order history once a purchase is made.
And each of those has a different tolerance for inconsistency.
Exactly.
Okay.
And the e-commerce platform might choose to prioritize the availability of the product catalog.
Okay.
So you can keep browsing,
Right.
even if there's a temporary glitch.
Right.
But the shopping cart and order processing systems,
Yeah.
those likely need stronger consistency guarantees
Right. To avoid those errors.
to avoid errors.
Okay. All right. So we've got data partitioning, treating different data with different CIP priorities.
Yep.
What about segmenting by operation type? What does that look like?
This comes down to recognizing that reading data
Okay.
and writing data
Mm-hmm.
have different implications for CIP.
Okay.
Reading data is considered safe
Okay.
because it doesn't change the underlying information.
So you can prioritize availability for reads, letting users just access the data quickly, even if the system's under stress.
Exactly, but when you write data, you're making changes.
Right.
And those changes need to be carefully managed to avoid inconsistencies
Okay.
or data loss.
So in a system with heavy read traffic,
Yeah,
like a news website or
Yeah.
a social media feed,
right.
you might prioritize availability
Yeah,
for those read operations.
exactly.
Even if it means the latest comments or posts take a few extra moments to appear for everyone.
Exactly.
Okay.
But for write operations,
Yeah.
like posting a comment
Right.
or making a purchase,
Yeah.
the system might favor consistency,
Okay.
even if it means a slightly slower response time, just to make sure that data is properly recorded
Right.
and reflected across all servers.
Got it. Got it.
Yeah.
It's about choosing the right strategy for each piece of the puzzle.
It is. It is.
So we've covered data operations.
Mm-hmm.
What's next on our segmentation tour?
Let's zoom out a bit
Okay.
and think about segmenting by functionality.
Okay.
This involves dividing a larger system into smaller,
Okay.
more manageable services or modules,
Right.
each with its own CFP needs.
So instead of looking at individual data points
Right.
or actions, we're thinking about whole chunks of the system.
Yeah, think of it like a ride-sharing app.
Okay.
You might have different services for user accounts,
Right.
mapping, matching riders and drivers, and payment processing.
And each of those might have very different requirements when it comes to CAP.
A perfect example, and each of those services
Yeah.
might have very different requirements when
Yeah.
it comes to CAP.
Yeah.
User accounts might need high availability.
Right. So people can log in,
Yeah.
request rides, even if there's a temporary glitch.
Yeah, but payment processing
Yeah.
needs strict consistency
Okay.
to ensure accuracy and prevent fraud.
Yeah. You don't want to mess around with people's money.
You don't want to mess around with people's money, exactly.
I'm starting to see how complex this can get,
Yeah.
but also how powerful it is to be able to tailor the approach to each specific part of the system. It's like having different tools in your toolbox and knowing when to use which one.
That's a great way to put it. And the more complex a system becomes,
Yeah.
the more critical this kind of strategic thinking becomes.
Right. Okay. So we've got data, operations, functionality as ways to slice things up.
Yep.
You mentioned user segmentation too, right?
I did.
That one seems a bit more
It can be.
controversial.
It can be, but it's often driven by practical concerns,
Okay.
like performance and legal requirements.
Yeah, I imagine geographic location could play a role.
Absolutely.
Like a global service might need to store user data in different regions
Yep.
to comply with local laws
Yep.
or to reduce latency.
Exactly. And that leads to interesting CCAP consideration.
Right.
Do you prioritize consistency, making sure all user data is synchronized across all regions?
Okay.
Or do you prioritize availability, allowing users to access their data quickly
Right.
from the nearest server,
Yeah.
even if it means accepting some level of inconsistency between regions?
That's a tough one. It seems like the right answer depends heavily
It
on the
does.
specific service and the types of data.
Absolutely. And that's why understanding these trade-offs is so crucial.
Right.
There's no one-size-fits-all solution.
It's like we're building a custom design suit
Yeah.
for each system, making sure every piece fits perfectly.
I like that analogy.
Okay.
And just When you think you've mastered all these different ways to segment a system,
Uh-oh.
there's another layer to consider.
Oh, no, don't tell me there's more.
There is, but it's actually a way to bring everything together.
Okay.
It's called hierarchical partitioning.
Okay, lay it on me.
Here.
What is hierarchical partitioning?
Imagine a pyramid.
Okay.
At the top, you have a global view of the data
Okay.
with looser consistency requirements.
Okay.
As you move down the pyramid, you get more specific
Okay.
with tighter consistency
Okay.
and potentially lower availability.
So it's like those Russian nesting dolls. Each layer contains another, each with its own level of detail and its own CAP strategy.
Precisely.
Okay.
This allows you to fine-tune your approach at different levels of granularity.
Okay.
For instance, you might have a globally available cache of frequently accessed data at the top level,
Okay.
while ensuring strict consistency for individual user transactions at a lower level.
That's incredible. It's like having a zoom feature
Yeah.
for your CIP strategy,
Yeah.
allowing you to adjust the focus, the precision based on the specific need.
You're getting it, this hierarchical approach.
Okay.
It helps manage complexity.
Yeah.
It ensures scalability
Okay.
and allows you to optimize for both consistency and availability in different parts of the system.
This has been an eye-opening exploration of segmentation.
It is a powerful concept.
But before we wrap up, I have to ask,
Okay.
what does all this mean
Yeah.
for the future?
Yeah.
How will the CIP theorem continue to shape the way we build and interact with technology?
Right. That's a great question, because the challenges and solutions are constantly evolving,
Right.
particularly as distributed systems become even more prevalent and complex.
So we've talked about all these different ways to segment systems and kind of manage those CIP trade-offs.
Right.
But what are some of the big trends that are going to make this even more challenging going forward?
One of the most pressing issues is scalability.
Okay.
As systems grow to handle more users, more data, more everything,
Right.
the complexity just explodes.
Yeah.
And those gappy choices get even harder.
Because adding more servers, more connections,
Yeah.
that just introduces more points of potential failure.
Exactly. It's like a game of Jenga.
Okay.
You can carefully build a pretty tall tower,
Right.
but the higher you go, the more precarious
Yeah.
each block placement becomes.
Right, right.
And in a massive distributed system,
Yeah.
even small glitches can cascade into major outages.
So even if you're not dealing with like a literal network split, just the sheer volume of data and traffic can create CAP-like challenges.
Precisely. Imagine like a global social network
Okay.
with billions of users.
Right.
Even if the underlying network is rank solid.
Yeah.
Coordinating data across all those servers.
Right.
Ensuring consistency.
Yeah.
While maintaining responsiveness.
Right.
It's a monumental task.
It's making me think about like those flash sales where like a hot new product goes online and suddenly the website is just slammed with traffic.
Yep.
Is that a CAP scenario in action?
Absolutely. That's a classic example of how scalability can expose the limitations of CAP.
Okay.
If the website prioritizes consistency, making sure everyone sees the same inventory numbers, it might slow to a crawl under heavy load, frustrating users who just want to buy the product.
Right. But if it prioritizes availability, letting people add items to their cart, even if inventory's running low, you risk overselling and having to deal with like cancellations and angry customers.
Yep. It's a tightrope walk.
Yeah, it's a no-win situation.
It is. It is.
Okay, so scalability is one big challenge.
Right.
What else is keeping engineers up at night when it comes to the future of CAP?
Security is a huge concern.
Okay.
As systems become more distributed, more interconnected, they also become more vulnerable to attacks.
Right. I can see how a denial of service attack, where hackers flood a system with like bogus traffic that could easily create a CAP-like scenario.
Exactly.
Right.
Suddenly, legitimate requests can't get through.
Right.
Servers are struggling to keep up. And you're forced to make those tough choices again. Prioritize consistency and risk becoming unavailable. Or prioritize availability and risk data corruption or inconsistency.
It's like the system is under attack.
It is.
Both externally from the hackers and internally from the constraints of CAP itself.
That's a great way to put it. And this is why the future of CAP is about more than just choosing between consistency and availability. But it's about building systems that are resilient, adaptable, able to gracefully degrade under pressure.
Okay.
Whether that pressure comes from organic growth or malicious intent.
So it's not just about picking 2 out of 3 anymore.
Right.
It's about finding like creative ways to bend the rules, push the boundaries of what's possible.
You got it. And that brings us to another exciting frontier.
Okay.
Mobile devices.
Ah, right, because smartphones and tablets, they're basically mini distributed systems themselves.
They are.
Right, constantly dealing with unreliable connections, syncing data, trying to provide a seamless experience even when things go wrong.
Exactly. And for mobile app developers, CAP considerations are front and center.
Right.
You have to think about how the app will behave when it's offline, how to synchronize data, when a connection is restored, and how to provide a good user experience, even when dealing with latency and intermittent connectivity.
It seems like designing for mobile almost forces you to embrace eventual consistency.
It does.
Right. Accepting that data might be temporarily out of sync because the alternative, constantly blocking the user while waiting for perfect consistency, would be terrible.
It's a trade-off, for sure.
Yeah.
But it's one that mobile developers have gotten quite good at managing.
Right.
Think about offline maps, for example.
Okay.
You can download map data ahead of time.
Yeah.
Use it even when you're offline.
Right.
And then sync any changes later when you have a connection.
It's like having a little piece of the cloud in your pocket, ready to go.
I like that image.
Okay.
And this trend of pushing processing and data storage closer to the edge.
Yeah.
Closer to the users and their devices.
Yeah.
This is going to be huge for the future of CAP.
So we're going from like these giant centralized data centers to this more distributed model where CAP considerations are everywhere.
Yeah.
From the massive cloud platforms down to the individual devices in our hands.
Exactly.
That's fascinating.
It is. And it all circles back to those core principles.
Oh, okay.
Understanding the inherent limitations of distributed systems, making strategic choices based on specific needs, and constantly innovating to find new ways to deliver reliable, scalable, and secure experiences in an increasingly complex world.
Wow. Okay, I think our listeners' brains are officially full.
Full of CAP.
We've covered a lot of ground today. What are some key takeaways you hope they'll remember from this deep dive into CAP?
First and foremost, the CAP theorem is not about finding the right answer.
Okay.
It's about understanding the trade-offs and making informed decisions that align with the goals of your system.
So it's not like a rule book.
Right.
It's a framework for thinking.
Yes, exactly.
About the challenges and opportunities of distributed systems.
And secondly, CAP is not just an academic concept.
Okay.
It has real-world implications for how we design, build, and use technology.
Right, in every aspect of our lives.
From the websites we browse to the apps on our phones to the critical infrastructure that powers our modern world.
It really does.
Precisely. And as technology continues to evolve, the CAP theorem will only become more relevant.
Right.
It's a powerful lens for understanding the complexities of the digital world and for shaping the future of technology.
Well said. On that note, I think it's time for us to wrap up this deep dive.
Okay.
But before we go, I want to leave our listeners with a thought-provoking question.
Okay, I'm intrigued. Go for it.
We've spent this whole episode talking about how CAP applies to digital systems. But could it be that similar principles are at play in other complex systems, like social networks, economies, or even like biological ecosystems?
That's a fascinating question to ponder.
Right.
It suggests a deeper connection between the digital world and the natural world.
Right.
A shared set of constraints and opportunities that shape how systems evolve and adapt.
It's definitely something to think about. And with that, we'll leave you to your own deep dives.
Yeah.
Thanks for joining us on this exploration of the CAP theorem.
It's been a pleasure.
Yeah, it has.
Until next time.
Okay.
Keep exploring, keep questioning, and keep diving deep.